theorem, copy the diagram and write the circle theorem. Circle theorem 1. Angles in a semicircle are 90 degrees. Here, the line AB is the diameter of the circle, and the angle ACB here is 90 degrees. Pause the video, copy this diagram and calculate the size of each of the unknown angles. Remember to find the angles in alphabetical order. Although you may be able to find angle E, this one here, once you've found angle A, don't. These are easy questions, and once they get harder, you will appreciate why you should find the angles in alphabetical order. For each answer, give an appropriate angle fact. Once you have found all the angles, resume play and check the answers and fact. So, pause the video. Angle A here is 37 degrees, because this triangle here, that's the radius of the circle, that's the radius of the circle. So this triangle here is an isosceles triangle, and angles at the base of an isosceles triangle are equal. Hence, angle A is 37 degrees. Angle B, this one here, is 53 degrees. This is because this line here, oops, I've lost my mouse. This line here is the diameter of the circle. And as we've found from circle theorem 1, that the angles in a semicircle are 90 degrees. So this whole angle here is 90 degrees. Because this is 37 degrees, 90 take away 37 is 53. Hence this angle B here is 53 degrees. Okay. Angle C is 53 degrees. Once again, this line here is the radius of the circle. This line here is the radius of the circle. Hence this triangle here is an isosceles triangle. And as we know, the angles at the base of an isosceles triangle are equal. So if B is 53 degrees, C must be 53 degrees. Angle D must be 74 degrees, because angles in a triangle add up to 180. This was 53, this was 53, hence D is 74. Angle E, you can find that as 106 degrees, this angle here, because angles on a straight line add up to 180 degrees. Circle theorem 2. The angle at the centre of the circle, the angle at the centre here, is twice the angle at the circumference here. In other words, angle AOC, this entire angle here, is twice the angle ABC. Okay, copy the diagram and find the missing angles in alphabetical order. Remember to give each angle fact for each answer. Once you've found the answers, resume play and check them. So, pause the video. Angle A is 29 degrees, because this line here is the radius of a circle, this line here is the radius of a circle, hence this triangle is an isosceles triangle, and angles at the base of an isosceles triangle are equal. Hence A is 29 degrees. B is 122 degrees, because angles in a triangle add up to 180. This is 29, this is 29, therefore B must be 122 degrees. Angle C, this one up here, is 61 degrees, because angles at the centre are twice the angle at the circumference. So if B is 122 degrees, C must be half of that, i.e. 61 degrees. And finally, angle D, this angle here. We're looking at this huge triangle here. We know that A is 29 degrees, so we know that whole angle. We know that angle C is 61 degrees, we've just found that out. And so, because angles in a triangle add up to 180 degrees, we take away this 29, this 29, this 41, this 61, and you get that angle D is 20 degrees. Circle theorem 3. Angles in the same segment are equal. The line AB, this one here, is a chord. So this whole area here is the major segment, and this little bit down here is the minor segment. Any triangle that's constructed using AB, this chord here, has an angle, this angle up here. And every triangle that you construct off the same chord will have the same angle here. In other words, angle ADB is exactly the same as angle ACB. And if I were to draw another triangle, whoosh, up there, go back down there, that angle there would also be the same. Okay, pause the video again, copy this diagram, and calculate the size of each unknown angle in alphabetical order. And remember to write the angle fact. Once you have found all the answers, resume play to check your answers and facts. So, pause the video. Angle A is 39 degrees. I've lost my mouse. Okay, this line here is the diameter, and as we found from circle theorem 1, angles in a semicircle are 90 degrees. So this entire angle here is 90 degrees, therefore A must be 39 degrees. Angle B is 46 degrees. So we're looking at this triangle here. So if this is 90 degrees and this is 44 degrees, this must be 46 degrees. Angle C is also 46 degrees. That is because this chord here has produced this triangle here. And this angle here has been shown to be 46 degrees. So using the same chord, if we construct this triangle up there, we get that this angle here is also 46 degrees, because angles in the same segment are equal. And finally, angle D is 51 degrees. This is because if you draw a line from here to here, then you can see that you have constructed this triangle here. So this time you have to draw the chord in. If you draw a chord from there to there, you can construct this triangle here, and this angle up here is 51 degrees. So any triangle that's constructed off this chord will also have a top angle of 51 degrees. So here is the chord, there, and there is the triangle that's been constructed off that chord. So therefore angle D is 51 degrees, because angles in the same segment are equal. Circle theorem 4. Opposite angles in a cyclical quadrilateral add up to 180. A cyclical quadrilateral is a quadrilateral, four-sided shape, that can fit into a circle so that each of the vertices, that's these corners here, touch the circumference. Okay. Here, we're saying that this angle here plus this angle here is equal to 180. In other words, angle DCA plus CBA adds to 180. And because angles in a quadrilateral add up to 360, so this angle here added diagram down, find all the unknown angles, don't forget to give me the angle facts, pause the video, and then restart it once you're ready. Angle A is 64 degrees because angles at the centre, this angle here, is twice the angle here. You can see there's the arrowhead that comes off there. So that is 64 degrees, which is half of 128. Angle B is 26 degrees. Once again, we have an isosceles triangle. Radius, radius. So if that's 128 degrees, you've got 26 degrees there, and you must have 26 degrees there. Angle D is 33 degrees. Once again, I have an isosceles triangle here, so there's 33, that must be 33. So E must be 114 degrees, because angles in a triangle, this one here, add up to 180. So I've got 33 there, 33 there, so this must be 114 degrees. Okay, and finally F, which is this angle here plus the whole of this angle here must add up to 180, because opposite angles in a cyclical quadrilateral add up to 180. And if I know that E is 114 and I know that C is 26, I can find out that F is 40 degrees. Circle theorem 5. For the following 3 theorems, I just want you to copy the diagrams, write down the theorem, and make suitable notes so that you understand the theorem. We will tackle the questions on all 8 theorems in class. So, circle theorem number 5. The perpendicular from the centre of a circle to a chord bisects the chord. Here, the line OM is the perpendicular, so I've got a right angle here, and the line AB is a chord, and this perpendicular OM has cut the chord AB exactly in half. So AM is the same length as MB. See if you can understand why. Think of congruency. Circle theorem 6. The tangent to a circle is perpendicular to the radius. The line AT, this one here, is the tangent, and OA, this line here, is the radius. So this angle here is 90 degrees. Circle theorem 7. Tangents from an external point are equal in length. The line PB, this one here, is a tangent, and the line PA is a tangent, and the point P is the external point. The theorem states that the line PB, this distance here, is the same in length as this distance here, PA. Remember, OA and OB are the radius. And from the previous circle theorem, where a radius and a tangent meet, that angle there is 90 degrees, that angle there is 90 degrees. So if this is a quadrilateral, these two angles must add up to 180 degrees. In other words, APB plus angle AOB is equal to 180. See if you can see why. Finally, circle theorem 8, the alternate segment theorem. Rather a confusing title for a theorem, but let me explain. The line PT, this one here, is a tangent. The line ST is a chord. Again, we have 2 segments, major segment, minor segment. What this theory is saying is that the angle between the tangent, this one here, and the chord is exactly the same as this angle here, which has been constructed using a triangle from the same chord. And from circle theorem 3, we know that this angle is the same as this angle. This is the alternate segment theorem. This is the end of the video.